Hello everyone. Today we're going to talk about a really interdisciplinary field related to computer science, the game theory. First, before jumping into the definition directly, let's look at an example. How do people actually set up the bidding rules for auction? Many people are working on this, and one way is to have the sealed bidding, where everybody places their bids in the envelope and hand to the auctioneer together at the same time. So no one knows other people's bidding price. The bidding price is private, and all the decisions are made independent of each other. The second way is the open ascending bidding, where people make increasingly higher bids. Process continues until no one bids higher. And the usual outcome of this is that the people who value the item highest will get the item at last. So which one do you think is better? And there's actually no answer for this question because they are all different metrics. And the game theory is trying to answer the question like this. Then let's go back into the definition. A typical game will have four parts. The first is players. In the auction is the bidders. In the second is the actions. In the paper rock scissors game, we can have three different actions. And in the auction, we can choose what price we want to bid for, or do we bid or not. The third is the payoffs for the outcome. In the auction, we can bid higher and get the item at last, or maybe we can bid lower, and if we don't get it, we have no loss, we have no won. And the fourth is the information. In the auction, we don't have any information about other people's value of the same item. So we can maybe choose a little bit less, and then we may not get the item, or maybe bid a little bit higher, but we may risk of paying too much. However, in some other game, the information is totally complete and transparent, like the chess or Go.
So here I'm going to introduce some hot topics in the fields of game theory. The first one is auction, as we described before. The second one is the fair division, which I'm going to give you a simple example for this problem. And the third one is the mechanism design. So a famous example for the fair division problem is the cake cutting problem. The thing of the problem is as following. First, n different people try to share the cake. However, cake may have different ingredients, which people may have different preferences over ingredients. So in this example, we might have Bob like biscuits more than kiwis or strawberries, while Alice will prefer strawberries rather than biscuits. So how do we make a fair division of a cake for those n different people? The first thing we will evaluate is the envy-free principle. So our algorithm will need to assign cakes in such a way that each one feels that they got the best deal. In other words, no one would want to swap places with other. This property is guaranteed when every partner feels that their allocated share is at least as good as any other's share, according to their own subjective evaluation. So another principle for the fair division is proportional, which means that every partner feels that his allocated share is worth at least 1 over n of the total, so that no one will be unsatisfied. So, in general, what makes game theory hard? Game theory is hard because some slightly change in the initial condition might change the entire game drastically. So, and go back to our cake cutting problem. What if the n different people is not sharing a cake, which you can cut infinitely? What if they are trying to share a finite set of elements like a few number of chairs or desks or even houses? So, why is it useful? Here are some typical scenes that will be used that is presented on the website called Splitit. This website is designed by Professor Prakashia in order to use game theory into real life cases. The first scenario is the share rent. So think about you're moving to an apartment with roommates. We want to create harmony by fairly assigning rooms and sharing the rents. So like someone will prefer bedroom over living room, and others might like second floor more than first floor. People might evaluate the price for houses differently. So how can we make this harmony? The second one is the split fare, where people are trying to split the fare for taxis. So there are mainly two CMU researchers working on this field of game theory. The first one is, as we described before, Professor Prakashir, working on fair division, voting theory, and cooperative games. The second one is Professor Sandholm, working on mechanism design, optimization, and auctions, etc.
There are many recent advances in game theory. One of them is the A/B testing of auctions. This paper appeared in the EC16, which is one of the most important conference in game theory. It's called the ACM Conference on Economics and Computation. A/B testing actually partitions users of a system into A, control group, and B, the treatment group, to experiment between several applications to optimize their services to the behavior pattern of their user. The paper combines auction theoretical modeling with the A/B testing framework to develop methodology for A/B testing auctions. And A/B testing is actually used in many other places, and this is the first time it uses A/B testing into auction. This also shows that game theory is a very interdisciplinary field. Another one is the paper called A Stochastic Game Without a Stationary Discounted Equilibrium. This paper is very interesting in that people assume there will be a stationary equilibrium in stochastic game for many years and use it in a lot of places like economics and political science and social science. However, the writer actually shows that and give two counterexamples to show there's no stationary equilibrium point, where amazes many people who use this as a ground truth. There are also many open problems in game theory. The first one is how people learn from their actions and corresponding payoffs. This is also related to reinforcement learning because people may not play the best response at the beginning of the game. However, they may be developing their strategies as the game develops. And another one is what's the equilibrium notion accounts for the real world behavior. This is also related to psychology, since we began to assume that people are rational. They will play according to their self-interest in the game. However, this is not actually true in many places because some people are bad, they want to harm other people, or some people are more kind and friendly. They maybe sacrifice a little bit their self-interest for the greater good of other people. That's all for our time. Thank you very much.